Hello everybody, how are we all doing today? Hope everyone's having a good day, evening, night, whatever time you're celebrating right now. Let's go over some vertical shifts of sine and cosine graphs. Let's take this super basic so that none of us get too lost and you kind of have an idea of what's going on. Say I was going to graph a linear function, right? And let's call this one y equals x plus 2. If I wanted to make this y equal, go up here, right, you would add 2 more because, okay, these are parallel lines, blah, 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 blah. We would call it x plus 4, right? So when you were moving this graph, whether it was up or down, you were adding or subtracting a number to the function, which in this case was linear. That's called a vertical shift, and those vertical shifts can go up and they can go down. You can do the exact same thing in the exact same way with sine and cosine functions. So here are some examples. So here's our form. We already went over the amplitude, frequency. Now what happens when you add a number or subtract a number to those sines and cosine functions? So let's take a look at that first one, and it's going to make complete sense to you. So here is y equals cosine x. That's this blue line that you see curving away over here. Then they graphed y equals cosine x plus 2. So if you look, that here it's at 1, right? Now all of a sudden it's at 3. So it shifted this whole graph up 2 spaces. Okay, that's it. Okay, so try not to overthink it too much. So what did the value of d do to the graph of y equals cosine x? And what type of transformation is it? It moved up 2 spaces. And they call this a translation. Okay, for all you geometry buffs out there. Okay, so this was a vertical translation moving up 2 spaces. Now, what happens when we do that, okay, because when we were graphing all of these functions here, we were using this x-axis here as our reference point. Now, that was telling us kind of where we're going up and where we're going down, when we're going to hit it, right? And that was at pi over 2 and pi, 3 pi over 2 and 2 pi. Well, now when all of a sudden you start shifting it, you're kind of just hanging out an empty space. That line still exists, okay? So that's important that you remember this line still exists. So it kind of magically moved up with shifting that graph. Now in trig, we have a name for that, and that's called the midline, okay? Midline, okay? And so when you shifted that up, that shifted the midline up. Now, what would this name be in math world or in math terms? What would this midline be called? What was his equation? Well, it's a horizontal line that crosses the y-axis at 2. It would be y equals 2. So that would be the equation of the new midline. All right, so let's try to answer the same question again by graphing cosine x and then cosine x minus 1. Okay, so now, in the other one we did a positive 2, now we're going to do a minus 1. So what did the value of d do here? Vertical shift. Be careful. Shift down 1. And what type of transformation? It's still a translation. Now what would the equation of the midline be? Well, you brought the whole thing, you brought basically this x-axis down 1 space. So there is my midline now. And what would his equation be? That would be y equals negative 1. So try not to get yourself too confused or too wrapped up in all of the craziness that are this brand new topic for you. So here's a summary of everything you did. So for curves that have general form y equals a sine bx plus d and a cosine bx plus d, the value of d represents the translation of a vertical shift. So vertical vertical shift. And that shift can either be up when it's positive, down when it's negative. Okay? The value of D also represents the midline of the trigonometric function. It is the horizontal line, it's like that x-axis, that the sinusoidal curve, sine or cosine, rises and falls above and below by a distance of whatever the amplitude is. Okay. So in this particular case, so midline, remember, is in the equation of y equals, so it's whatever that d value is. And if you look at that last examples we did, this first one we said that the midline was y equals 2. There it is there. And in this one we said that the midline was y equals -1, which it is down there. Okay, so here's your sine curve. So I know I went up 2 units, right? So this whole thing moved up to 2. So the midline would be right there at y equals 2. So if the graph, if given the graph, the equation of the midline can be found by taking the average of the max and the min. So let's pretend for a second you don't have an equation. You look for the highest point, that's called the max, and you would look for the lowest point, and that's called the min, and you find the average. To find the average, you would add them up and divide by 2. And in this particular case, the max was 3, the min was 1, so 3 plus 1 is 4, and 4 over 2 is 2, showing y equals 2. All right, so good so far. So let's take a look at some examples. So it says state the range and the equation of the midline for each graph. So again, I don't have the equation to just find the value of the d, so that positive or negative, so I could just say what it is. So what I would do, I would say, okay, the max, or the range in this case, let's start with that. The range is the y moving from the bottom of the graph up. So on the bottom of the graph on the y is here at -5. The top of the graph here on the y is -1. So the range goes from the lowest point, which was -5, to the highest point, which was -1. Now to find the midline, you would just do the max and the min divided by 2, which is -3. And that's right here, y equals -3. Pause, try the next one. Range and midline. So the highest point and lowest point. So the lowest point here was -6. The highest point here was +4. To do the midline, I would take the max and the min, add them up, divide by 2, and that's going to give me -1. So the midline is here at y equals -1. All right. Hope this is helping. Hope we're good so far. Trying to move nice and slow for you so that everybody kind of stays with me. So now let's go to graphing this. So now, yes, you can go ahead and throw this into your calculator, and it's going to spit it out. If you're good, we did that in earlier videos, graphing. But when you start to graph with the shifts, sometimes you can get a little lost because it's not, again, that midline, that x-axis, isn't the x-axis anymore since it got shifted up and down. I think it would be good to throw that into your calculator so you can kind of get a general idea of what it's supposed to look like, and then kind of use our notes here on how to graph it by hand. So they're going to be graphing this one over the interval from -2 pi to a +2 pi. So you're going to be going from pi over 2. What do I do? Skip one. Then I would do pi. Then it's 3 pi over 2. And then it's 2 pi. And then you're going to do the same thing going in the negative direction. negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So there it is. So now let's look again how to graph this by hand. It doesn't take too long, and the more you practice it, the quicker you'll get with it. So we start by figuring out the amplitude. That's the number in front. That's going to be, in this case, the absolute value of negative 1, and that's going to be 1. Then what you can do is you can go ahead, we can figure out our frequency. The frequency, remember, is the b value. That's the number, okay, with that touching or attached to that x, and in this case it is 1. And then now what we're learning is the shift, and the shift is moving up 1. So now again we're going to be graphing the sine curve. Now it's important that you know what our critical values of the sine curve is. Now again, if you're good, this is what a sine curve looks like. And if you have that general idea, it's pretty easy to figure out your critical values. So here you're starting at 0. So your critical values are 0, 1, 0, negative 1, and 0. So you can see that 0, 1, 0, negative 1, and 0. Now what you're supposed to do is multiply those numbers by the amplitude. So you would go ahead and use kind of like your distributive property and multiply all of that. And nothing's going to change. So you'll have 0, 1, 0, negative 1, and 0. Now what happens is you have to shift this entire graph up 1. So what you need to do is you need to add 1 to all of the critical values. So 0 plus 1 is 1, 1 plus 1 is 2, 0 plus 1 is 1, negative 1 plus 1 is 0, and 1 plus 0 is 1. So that right there is going to be the new graph. So it's going to look like this. Okay, I'm just trying to help you with this and just kind of show you a reference point. Now you're going to shift the whole thing up 1. And if you look carefully there, that's kind of going to show those numbers here. So at 0 here, let's skip 1, we'll do 1, skip 1, and we'll do 2. So first, the first value is 1. Then the next value is 2. Your next value here is 1. Your next value is 0. And then here it's 2 pi. Okay, and I'm using these numbers here. So this was at the 0, this was at pi over 2, this was at pi, this was at negative 3 pi over 2, and then this one was at 2 pi. I got a little ahead of myself there because remember we have to figure out the period by doing 2 pi over b, and that's 2 pi over 1, and that's 2 pi. So remember, the period tells me how long it took to complete one cycle, okay? How long it takes to complete one cycle. And for this case, it was nice and easy. The next one you'll see. So there is a beautiful sine curve, if I do say so myself. Now, we have to go ahead and do the other side. Basically, just kind of do the same thing, but backwards. So at 0, then it's going to hit at, instead of, it's going to go here, and then it's going to go there, and it's going to go here, there, and then there. Okay, so it kind of does the same thing. You just kind of keep going with that same curve. All right, now state the equation of the range and the equation of the midline. So the range, the lowest point of this graph was 0. The highest point of this graph was 2. So there you go. There is your range. Now, oh, I can't believe I just did that. And all of you are sitting here watching me, and not one single person chimed in and said, hey, Cornell, you're doing this entire thing wrong. I am terrible. Now the question is, do I want to sit here and redo this whole entire video again? No, I don't want to redo this whole entire video. That would just be ridiculous. I'm gonna. Why? Why did I even do that? I'm a terrible person. Look, it's a positive 3. Why did I do a positive 1? I don't know. I was getting excited for this. So really, all of these numbers, instead of being adding 1 here, it's going to be adding 3. So all these numbers have to go up 2 more spaces. Oh, such a dilemma. So it's a good thing you guys all write in pencil, because then you could just erase it like I am about to do right here. Look. So it's not going to be too bad. Just a little mistake. And I caught my mistake, so I didn't lose any points because you didn't grade it yet. Oh, so sad. We were doing so awesome here. So 0 plus 3 is 0, plus 3 is 3, 1 plus 3 is 4, 0 plus 3 is 3, negative 1 plus 3 is 2, 0 plus 3 is 3. Well, this is good because if you got lost, then you can just watch me do it again. All right, so here we go. Skip 1, that's a 1, skip 1, that's a 2, skip 1, that's a 3, skip 1, that's a 4. All right, so let's do this all again. All right, so at 0, we're going to start at 3. At pi over 2, it's going to be going up to 4. Because again, now I can say I didn't get ahead of myself. I actually got nowhere. This is going to be 1 cycle. And this is 1 cycle of a sine, and it has to do that between 0 and 2 pi. Okay, now let's keep going. Then at pi, I'm at 3. At 3 pi over 2, it's at 2. And at 2 pi, it's back at the 3. So then there is an even nicer sine curve than the one before. Now since again, I had to go to negative 2 pi, I'm just going to kind of continue that back around. So here I'll go down to the 2. At pi, I'll return back to 3. Negative 3 pi over 2, I'll max out at 4. And then come back down to Earth at negative 2 pi. Ooh, that should be 3. There's the 3. All right, so there it is. There it is. Much better looking and also correct. All right, let's do the range here. So now the lowest part of this graph is 2, and the highest part of this graph is 4. State the equation of the midline. Okay, so the midline can be done by taking the max and the min, adding them up. That's a 2. Dividing by 2, and that's going to give me 3. So the midline is at y equals 3. And if you don't believe me, then since I have this smart sphere right there, ooh, that's ugly. There's y equals 3, and if you notice how beautiful that looks there. All right, so there we go. Hopefully you didn't get too lost. Maybe it helped you because I did it twice. All right, let's try problem number 2. And the whole reason I keep saying, oh, the calculator might not really help you too much. Well, what about this one? There's nothing actually put into a calculator. So on the axes below, graph 1 cycle of a cosine function. So right in my head, boom, pops into there. This is what 1 cycle of a cosine function looks like, from 0 to 2 pi. So the amplitude, let's go over here. So the amplitude was 3. The period was pi over 2. So again, that's the part I think that some of us can get the most lost on. So the period tells us how long it takes to complete 1 cycle. So on a graph, I have to see this, and it has to go from 0 to pi over 2 to do that. All right? So that's what period means. The midline, so the midline is y equals negative 1. So pretend like this guy isn't even there, and you can always just draw in a new one, right? So I can do that with this and say that's going to be there, and that's going to confuse me. That is going to be your midline, or where your new kind of where you're going to be paying attention to is going to be. All right, so let's go. First, let's get rid of that ugly midline. And let's figure this out. So did I take everything they gave me? Oh, and then it has to pass through that point 0, 2. So I'll have to keep that in my back pocket, right? So first, figure out what are my critical values of a cosine. Him. So it's going to be 1, 0, -1, 0, and 1. 1, 0, -1, 0, and 1. Now, the amplitude was 3, so multiply everyone by 3. 3, 0, -3, 0, and 3. Now, since the midline is -1, what did we learn earlier? What is a midline? Midline is telling you the shift. So this entire graph moves down 1. So I'm going to subtract 1 from all of these numbers. So my new critical values are going to be 2, 3 minus 1 is 2, 0 minus 1 is -1, -3 minus 1 is -4, 0 minus 1 is -1, and 3 minus 1 is 2. So those are my new critical values. Now all of those values have to occur on the period. So this is going to be 0, and then this is going to be pi over 2. So remember before I was doing all the way to 2 pi and I said you're 0, you're pi over 2, you're pi, you're 3 pi over 2, you're 2. Okay, those were the 5. But not in this case, no, because it has to happen. You have to see that between 0 and pi over 2. So this is where you're starting. Skip 1, 1, skip 1, 2, skip 1, 3, skip 1. This is not going to be 2 pi anymore. That's just going to be pi over 2. So now let's use those numbers. 2, -1, 1, 2, 3, -4, -1, +2. And then this is your new graph. And then this here is your new x-axis, or the midline. All right, let's see. Let's take the range. The lowest spot was here at -4. The highest spot there was 2. So there you go. There you go for number 17. All right, moving right along. Final page. Let's kind of wrap this up and see if we were able to do it. State the range of each function. So we kind of have to do all that work we did earlier. It'll go a little bit quicker so that you'll be able to figure out where's the lowest and highest point. Some of you might say, I'm just going to throw it in my calculator. Go ahead, throw it in your calculator. But just be careful because you can't use the window. All right, so first, really what we need to figure out, okay, how high and low did it go? What was its amplitude? And did it move anywhere? Did it go up or did it go down? So we're concerned about our amplitude and our shift. Now, since this is a sine curve, again, you want to have those critical values memorized, and those are 0, 1, 0, -1, and 0. Then you're going to multiply everyone by 7. So it's always kind of these same steps. So it's going to be 0, 7, 0, -7, 0. Then we take the shift, and that means you're going to add 4. So this is multiply. And then this is going to be an add. So 0 plus 4 is 4. 7 plus 4 is 11. 0 plus 4, -3, and 0 there is 4. Right there, that's it. So the lowest point, your min, was -3. Your highest point, your max. So then that means that the range went from -3 to 11. All right. Hit pause. Try the next two. It's the exact same thing. Welcome back. So, cosine function, critical values now are 1, 0, -1, 0, and 1. Your amplitude is -5, so you're going to multiply that. So that's -5, 0, +5, 0, -5. Then your shift is going to be a +3, so you're going to add 3 to those. So you're moving this whole graph up 3. So that's going to be negative 2, 0, 8, 0, negative 2. So now what is the lowest point? The lowest point was negative 2 and the highest point was 8. So there's your range. And the final one, now this might look a little different. You say, well, what about this? Well, that's your frequency to find your period, which has nothing to do with finding the lowest and highest point. You're still going to figure out what your critical values are and find the max and min from there. So here we're looking at sine, so it's 0, 1, 0, negative 1, and 0. Take your amplitude, which is negative 25, and multiply. So you're going to have 0, negative 25, 0, positive 25, and 0. Now you're going to take your shift, and in this case you're going to subtract since it was negative. So now you're going to have 0, negative 60, 0, negative 10, and 0. So the lowest point was negative 60. And your highest point was negative 10. And that, if you're using your calculator, would have thrown you off a little bit. All right, now let's wrap this all up with our one final example. Graph and label 2 cycles of this function, state the range of the function, and the equation of the midline. So, okay, right away I'm going to say, I'm going to just kind of draw this out what I see in my head. So all cycles, okay, we'll go to 2 pi, right? And it would go, since it's a cosine function, it would go and it would look something like this, right? Now since it said it wanted 2 cycles, I would have to do it again. So this graph is going to go all the way out to potentially 4 pi, depending on what the frequency and period is. So we'll start by doing all of the work we just did and just keep following that pattern, and it shouldn't be too bad for you. So this is a cosine function, which means that my critical values are 1, 0, negative 1, 0, and 1. 1, 0, negative 1, 0, 1. The amplitude here was a positive 3, so let's multiply that. 3, 0, negative 3, 0, 3. Now there was a shift of negative 2, so I have to subtract all of these values by 2, so 3 minus 2 is 1, 0, negative 5, 0, and 1. Okay? Now, let's figure out how long it took to complete one cycle in this question. The frequency was x over 2, which means it's 1/2. To find the period, you would do 2 pi over b, 2 pi divided by 1/2, so 2 divided by 1/2 is 4, so it's 4 pi, right? So it took, this is 0, this is 4 pi, to complete one cosine function, right? It took 4 pi to complete one cosine function, okay? So they want 2, so we have to go all the way to 8 pi, because that would be 1 cycle, and that would be 2 cycles, all right? So we're going to have to be careful here. So it's going to go, let's see, the highest it's going to go is 1. I'm sure my face might be getting in your way. So let's go here. And then 1, 2, 3, 4, 5. The lowest is going to be negative 5. So I'll do skip 1, 1, skip 1, that's 2 pi. No, I'm not going to be able to. Skip 1, 2 pi, skip 1, 4 pi, skip 1, 6 pi. All right, so that's the way it's going to have to go. So here I'll put pi, skip 1, 2 pi, skip 1, 3 pi, skip 1, 4 pi. Oh no, skip 1. 5 pi, skip 1. That's not going to fit. This is going to be real ugly in a second. Here we go. So that's going to be too thick. So let's see. So it's going to be have to be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. All right, so here we go. I have to complete this from 0 to 4 pi. So there you go. And I'm going to hit those numbers. So we're going to start here at 1. Then it's going to be 0. Then it's going to be, well, 0 is not 0 because where's my midline, right? Let's figure out where the midline is. So the midline is your midline, right? So your is going to be -2. So really now your 0 is at -2. Don't forget your midline. There you go there. At 2 pi, you're -5. At 3 pi, you're back at 0. I'm pointing like you can see that. And it's there. And then at 4 pi, you're back at 1. So watch this. Here we go. That is one cycle of a cosine function. It started. Okay, ignore this line right there. I'm pointing again, like you can see. And then you're paying attention to this line. So basically, just do this again from here to there. So it's here. Then you hit 0. Then you hit -5. Then you hit 0. Then you hit 1. So that's... did it. All right. The range went from the lowest point of -5, highest point +1. And what else did they want? And the equation of the midline, which was right here at y equals -2. There we go. Finished all of our shifts. We were probably going pretty good until we got to the end there. Remember, hit pause, rewind, watch it again. Hope this helps. Like, comment, subscribe. Tell your friends.